So let's talk about the periodic table. As a chemist, I really like the periodic table. There's so much information that we can discover, and learning a few things about it, there's just a lot of things we end up not having to memorize because the periodic table kind of reveals it to us. So periodic means that it's repeating, so it happens periodically. So the periodic table has a repeating pattern. The most prominent person that gets credit for the modern organization of the elements is a Russian chemist named Dmitry Mendeleev. In late 1800s, he arranged the 60 or so known elements into groups, and those groups all had similar properties. And he ordered them in order of increasing atomic weight. And that kind of came to the precursor of what we have now. Now, ours aren't ordered in atomic weight. They're in order of the atomic number, so the number of protons that they have. And they didn't know all the elements we have now, but it really is amazing and imaginative to me that without even knowing how many elements there would be, Mendeleev and others would group the elements with ones that had similar properties, even so much that if there was one that didn't match, they might put it in its own group, or they would leave holes for elements that they thought there must be something missing there, and we'll discover it later. So I think that is kind of a cool thing. So one thing we have to learn, though, about the periodic table is how we describe it and what are words we use to talk about it, so it makes it a little bit easier. So looking at the periodic table, it has rows, which means it goes across. So if I drew a line right there, that would be a row. And we don't usually call it rows, we call them periods. Now on many periodic table, you'll notice that each row has a number in front of it. Even though the first row only has 2 elements, we still call it still number 1. And so what the line I drew a line in what we would say is period 3. Okay, so period would simply mean to me row, and then 3 tells me it's the third one down. Okay, so that's not too bad. Then we also if you think about it, we have columns. So if I drew a column right here, okay, so that's a column going up and down, and we call the columns groups. Sometimes they can call them family, but in general, a little more modern are the groups. And when we look at the groups, one thing that's kind of cool about them is the groups, the elements in the groups, how it was organized, is that they have similar chemical properties. And we won't learn about why this section, but later in the chapter we'll learn about why elements in the same group would have the similar electronic and chemical properties. Now if you look at the top of the group, and again this periodic table is pretty small, how I had to set it up on the lecture, but if you use one that I've given you, or maybe look at one that you have in your book or at home, you'll see that in this case there's 3 different numbers that describe that group. They don't all 3 have to be there. I just want you to know that those 3 numbers describe it. So the most traditional way would be a Roman numeral and a letter, and the letter would either be A or B. So if you look in the group I'm in that starts with carbon, it's Roman numeral 4, letter A. And if you look at the regular number, so then a little more modern was to say just the letter 4 and then A. And then the most modern way is just to count over from left to right. And we would see that carbon is in the 14th column as you go left to right. So they would just label number 14. Now, in all honesty, labeling number 14 is my least favorite part because the letter A and the other letter would be B. They actually tell me something. So I prefer probably like in my own things, not necessarily, you don't memorize any of these things, but to me, I kind of prefer just the 4A. But my least favorite is just 14. But with that said, you need to still know that 14th means it's the 14th one over, right? So when we look, let's keep going down our notes to see. So this says rows. So that's our periods are numbered 1 through 7. Yep, I already showed you that, 1 through 7. And at the bottom of the periodic table, we have, if you look, this has a 6 in front of it and this has a 7. These guys actually fit in right here. If you're looking at their atomic numbers, they're kind of pulled out. And the old-fashioned name for these are right here. It's lanthanides and actinides. And here it is here, lanthanides and actinides. And those are just old-fashioned names for those two. It's based on the elements that are pulled out, where where it comes out of the periodic table. But the lanthanides are a part of period 6, and the actinides are actually a part of period 7. Okay, so let's keep looking, make sure we getting all these things. I've already mentioned this about the groups and how they're numbered, but there it is in your notes. They can be numbered 2 ways, either with numbers and letters or with just numbers 1 through 18. Okay, now what I also want to do, so in a previous video, we categorized the elements as metals, nonmetals, and metalloids. Okay, now we're going to do another categorization, and I'm going to erase what I have on this periodic table. You can go back in the video and look at it again if you want to see it and pause it. But I want to erase this, and then I want to label it the other 3 ways. So the first thing we're going to look at is something called over here the main group elements. Sometimes, and I may do it in this class as well, they're also called the representative elements. And we, a lot of things we do in this class will be working with the main group elements. So the main group elements have the letter A. So if we're looking, main group elements are going to be in these first 2 groups. Here they have 1A and 2A. If you notice in these, and again it's hard to see, you can go look at another periodic table that's bigger, okay? Those all have B's, okay? And these here all there have A's. So the main group elements are in those sections. So it's everybody in this section, okay? I don't know why I keep saying K, but all right. So all of these, everything with an A on top of its group. Those are all what we call main group elements. So that's one category. And then we have transition elements. Maybe I want to pick a more drastic color change. Okay, transition elements. So transition elements are the groups that have a B in front of it. And I always think B like bridge. There's B's on all of these here in the middle. So all of these in the middle are called your transition. Sometimes they're called transition metals. This one in the notes is transition metal elements. So sometimes people will just say transition metals or transition elements, either one. So they're all in the middle. And then the last big category, and maybe you can see looking at this picture, there's only one little section left. These are called inner transition metal elements, or sometimes they just call them inner transition metals. So if they drop off one at the metal, or it's okay, but they're always called inner transition. And these right here are the inner transition. Okay, so that's another group. Now again, you don't have to memorize each element that's in there. You'll have a periodic table to refer to. But if I said what group or what part of the periodic table bromine is in, so if I find bromine right here, okay, so if we were discovering, let me use a different color, since that's what I like about colors. Red. Okay, so here is bromine, right? So that's bromine. So let's think, what do we know about it? Well, I can tell you looking over here, it's in period 4. Looking up here, I could say it's in group 7A or 17 if I was counting over. And then it is a part of the main group elements. So that's the kind of thing that you want to be thinking of when you think of this labeling. I don't have to memorize bromine is period 4 group 7A. I have a periodic table. So I need to memorize how it's labeled. So when I have a periodic table with me, I can understand the connections shown on the periodic table. Now there are 4 groups that have their own names. You're like, great. All right, so let's start. So here's the 4 groups. I think of them as bookends. So 1A, and it's everybody but hydrogen. So it's all of these guys. Hydrogen, remember I said in a previous video, is kind of a loner. So it's all of these, and so that's group 1A. Sorry. And that is called, those are called the alkali metals. I think that might not show. All right, that's 1A. Then we have 2A. So here's 2A right here, right? And it's everybody. It's only hydrogen that's kind of groupless. And these are the alkaline earth metals. Okay, so it's the first 2 columns have their own names. Then we have the other 2 that have their own names are 7A. So we look up here, here's 7A, and it's all, include this. And these are called the halogens. And then the last one is 8A. And these are called the noble gases. Whoops, sorry. I tapped it. Oh my goodness. I'm really close. I don't think I can. Oh. Oh. Okay, forget it. It's supposed to have an S there. Oh my goodness. All right, so there's the noble gases. Now, I did have a student one time tell me, because she was remembering the different names, but she had a hard time knowing you know, what order they were in. And I always think of it like the first 2 and the last 2 are the ones with names. And she pointed out to me that if you go down from here to here, they're in alphabetical order. So some of you, that may help as you're trying to learn and organize things in your brain. That may help you to know as you go, it's the first 2 and the last 2, and as you go left to right, the names are in alphabetical order. So, and these 2 questions, how do these groups illustrate that elements in a particular group have similar chemical properties? We'll talk a little bit more about that, but if you want to look in your book, on YouTube, if just Google alkali metals, which is the first group in water, and you will see how crazy it is. They all react with water violently, but as you go down the periodic table, it's even more and more violent. So it's kind of a cool thing. But if you look in your book, it will give you some characteristics of each one of those groups that kind of show you how, because they're in a group, well, not because they're in a group, but it shows you how the chemical properties of the group are similar. But look up alkali metals in YouTube, and alkali metals in water in YouTube, and watch a couple of the videos, and it's really kind of fun and interesting. Okay.